This
screen and
conference will now be recorded.
hello.
Yes, sir. Hello.
Can you guys hear me loud and
Yes,
clear?
yes. Yeah, it's clear.
And how about the screen? Has it been shared with you?
Yeah, I can see the screen.
Okay.
Yeah.
Uh, like we'll just wait for 5 minutes for a few more people to join in,
Okay, sir. No problem.
then we'll start. Okay.
Yes.
So we are just waiting for 5 more minutes for few people more to join in, and then we'll just start the meeting. I hope my screen and my voice is very much clear to you guys.
Yeah, now it is clear. Thank you.
Okay, okay. Okay, so we will start with the meeting. I guess okay, so I'll introduce myself. Myself, Anurag Mishra. I've been working as a piping layout and stress analysis engineer for past 11 years, and currently also I'm working the same field. And so basically today I'll be presenting myself before you as your guide for the PDMS designing and guiding you through this entire meeting or session, whatever you want to call it, how we will approach towards PDMS and why PDMS and why piping. This is what is the basic aim of the meeting. What we are going to learn. Say if we are an experienced engineer, we are a fresher, or like we are looking forward to somebody else from our zone to join piping industry. Why should he join? Or like what kind of training he should get from PDMS. So we'll get through that. So first of all, my question to over here, to everybody over here, is like everybody can hear my voice loud and clear. I'm very much clear to all of you, right? Just
Yes, correct.
Yes, sir.
Yes,
Yes,
sir.
it's perfect.
okay. And everybody can hear my screen. Sorry,
Yeah,
everybody
yeah.
Yes,
can.
yes.
Okay.
Yeah.
So, like if anybody has any query regarding PDMS or piping, you can just text me uh, in the comment section, or maybe after we finish with the session, then you guys can put up your queries, whatever queries you guys are having, and I'll take them one by one. Okay. So first of all, I'll just introduce you with PDMS, where we are using PDMS, and a lot of questions might be there in your mind that why PDMS, why not SP3D? Because lots of people, they come up to me and they say that why should we go for PDMS? Why not SP3D? Most of them have this question because these are the two software that are most of the time they are used in our industry. So this question is very much similar to a question which says that why Caesar? Why not Autopipe? It's that kind of a same question. Okay, so a simple answer to this is that why PDMS? Why not SP3D? Because PDMS is a basic software. If you're through with PDMS, you can easily understand SP3D. This is what is PDMS. So PDMS, if you are a rookie, say if you're just starting with piping industry, you get to know each and everything very much clearly. Like by clearly, I mean you get to understand all the inputs for piping from the word A itself, right from the beginning itself. This is how we move with PDMS. So that is why, as a fresher, if you're beginning, you should always approach to PDMS. If you're experienced, you must be knowing that yes, both the softwares are equally used, SP3D as well as PDMS. Okay, SP3D as well as PDMS. So what we'll be doing in this session is we'll be going through What are the requirements of PDMS? What will be our role as a piping engineer in PDMS? What we'll be getting to learn in our entire package, and what are the study materials that will be shared with you, right? This is what we are going to basically get through this session. So coming back to our presentation, we all know that whenever we are starting with piping, the first work that we do is your process flow diagram, your PFDs, right? This is what we work on first of all, your process flow diagram. Process flow diagram, what does that means? I'll just brief you out through all these terms once, and then we'll be getting on to our main work, what we desire in the piping industry and what we basically do in PDMS. Okay, so your process flow diagram, what does this tells? Process flow diagram is simple, that how your process is running. Like say if there's a process running from a column, there's a line going to your reboilers, or from pumps it's going to reboilers and then to your column. So that is your process flow diagram, that how the process is flowing from one equipment to the other and then to the other. That is how you construct. So based on your process flow diagram, the process team, they make up a PNID. Then when they are done with a PNID, they throw it to us, that look at the plot plan. These are the plot plans. We, as not more many people, they go into the plot plan team, but few of the experienced engineers, they set up into the plot plan team and they decide like what should be the plot plan of the entire layout. And then comes your civil layout. Civil layout, basically over here what they do is they study the soil properties and all, and then they plan it out, like what kind of structures, or what is going to be the exact thickness or the depth of the pelt and all. So they decide all of this over here. Then they come to the equipment layout over here. So in equipment layout, basically what we do here, we start, this is where we start as a piping engineer. Our role is obviously first of all to make the equipments, because the equipment GADs are finalized. Once the equipment GADs are finalized, they are thrown back to us. So after the finalizing of equipment GADs, we start making the equipments. Obviously we cannot question that equipment is a work of a static team or the rotating team. Okay, that whatever equipment that has been thrown up, we as piping engineers, we're not supposed to limit ourselves to piping stream only. We are supposed to manufacture design the equipment. By design I mean the 3D design model. So we will design the equipment, and then the main thing is placement of the equipments. That is one of the most important tasks. So designing of the equipment, and then placement of the equipment on the civil layout, that is the structures that are made, and then placement of this equipment layout on this thing, placement of the equipment on the structural members, where at which level it is supposed to be placed, at what level it is supposed to be placed. So after placement of this equipment, and very important thing over here is placement of the equipment has to be very specific. Let's like say for example, I'm talking about a heat exchanger, a shell and tube heat exchanger. So we all know that in shell and tube heat exchanger, a very important part is your tube. And when we are talking about the tube, the other important part that comes into mind is your bundle removal process. So what do we mean by bundle removal process? Simply that your tube must come out. Your tube must come out of your, wait, just hold on for a while. Okay, so what I was trying to explain over here, like say this is your GAD, this is your equipment layout over here, this is what you get, or your structural layout. Like say this is one of your levels, this is level 1, and over here what you're having is an exchanger. So exchanger, most of the time you must have seen in your entire experience that exchanges for the most of the time they are placed not in the center, they are placed somewhere at the periphery, or if they are placed in the center, proper care is taken that the bundle removal, the shell that is there, the tube that is there inside the shell, that has to be removed, so that while removal we take the complete distance into consideration, and before placing the equipment on the layout, that particular equipment on the layout, that bundle removal process is taken into mind before placement of that equipment. So this is important. In the same manner, there are a lot of equipment like pumps. Why most of the pumps they are placed at the bottom of the unit? As so the reason why most of the pumps they are placed at bottom of the units, like say this is your unit, so most of the pump we see that they are placed somewhere over here. Most of the pumps they are placed somewhere over here. These are, like you can imagine, these are your pumps. So most of your pumps are placed over here. Now why over here? Reason is because pumps are rotary equipments. We know this, pumps, turbines and everything, they know they are your rotary equipments. We have a special foundation for them, and these members, these equipments, they are placed at the ground level because they will induce vibration into the unit if they are placed on the any of the levels. Say if a pump is placed over here, it will a centrifugal pump, or might be a reciprocating pump also. So if you place a centrifugal or a reciprocating pump, it will induce a lot of vibration onto your uh, grating or onto your platform, and the entire platform might collapse in a longer run of a time, or in the longer run. So that is why we place your pumps at the ground level on the foundation. And same goes for your other equipments, like uh, say this thing, a reboiler. You must have seen that in case of your columns and a reboiler, in case of your columns and reboiler and a condensate pot, there is certain amount of distance to be maintained. You must have seen this. There's certain amount of distance to be maintained. Like if say this is uh, a line coming from this is a nozzle. This is a nozzle which is coming from a column getting into the condensate pot. This is a vapor line. There is some amount of distance to be maintained between this and the condensate pot. So there are some prescriptions from the process team also that we have to follow, that okay, we have to maintain this much of distance. So whenever we are working on an equipment layout, we have to keep into considerations these particular things, which like you'll be told in the through course of PDMS, you'll be guided through about these particular small things that which we should consider while going for an equipment layout. Because most of the time when we are planning equipment layout, we skip few of the major things. Like by major things I mean, like whenever you're planning an equipment layout, it's very important your equipment layout has to be such that your piping is the minimum. Okay, whatever piping you're using, whatever piping, say if there are two equipments over here, and you kind of place an equipment, it's just like you, I've seen a lot of plot plans, equipment layouts, where people they are not considering the small niggy things, but it plays a very important role. Say if you have fixed two equipments over here, and they are like facing each other, so there's a connection which is coming from this pipe to this pipe, you directly connect it from this. So you remember that this particular pipe, whatever you have connected, there's a direct connection, and say if it starts behaving like a transfer line connection, this is a big problem to you. So again, this line has to go into stress analysis. We know this. So your equipment has to be placed in such a manner that your piping has to be the minimum and your stress has also to be the minimum. So that is why what we do over here, when we are placing an equipment, we go for a very important thing that is called a single line study. After placement of the equipments, we go for single line study in order to just to know that what will be the maximum amount of spool that will be consumed in the entire piping run, maximum spool, and what will be the support locations, and also the amount of stress. Obviously, I mean, if we have been through the most of the piping, we know like how much stress is coming in the line and how much of load is being transferred onto the equipments. We can easily get through this. By this what I mean, it's simple, that the amount of elbows, the more the amount of elbows you introduce in a line, more the line becomes flexible, and the lesser the amount of elbows you have in the line, so line becomes stiffer. So this has to be properly understood, that the amount of elbows and the spool of the piping has to be a balance between the two. This is what is the scope of a piping engineer. This is what a piping engineer is supposed to maintain, that he has to maintain a balance between an elbow and the spool, because it's very easy to go like keep on adding spools and numbers, okay, number of elbows, because but remember, minimum amount of elbows has to be used. Why? Because elbows, they will increase the cost of the project. So minimum amount of elbows has to be used. This is what has to be considered in the piping. And the placement of the equipment has to be accurate. This has to be accurate so that your spool is minimum, number of elbows is minimum, and at the same time your stress has to be minimum. Because we see there's a lot of problem in the industry that placement of equipment is not exact. So when there's a problem with placement of equipments, there's a problem with the project, that your few lines, you'll get through few lines where your lines, they are actually not passing in stress, and so there's a lot of tussle between the stress team and your piping team. So that's why the placement of the equipment is very important. And once we are done with the equipment, then we come to our piping requirements, that like how we are supposed to move through the piping and everything. Then we prepare the piping layout over here, and obviously structural layout is being done by the other team. They go through the structural layout and the support layout and all. And piping layout, obviously when piping layout is done, we throw the isometrics, and then the detailing and the MTOs has been taken out, and then it's shared with the procurement team and all, so that they can start like throwing the quotes to the vendors. So now how we'll begin this. Obviously this is a PNID. This is what we'll be working through. This is your PNID on what your entire project will be decided. Okay, like we'll be having one small project in our PDMS training session, where we'll be deciding that okay, this is the work that we are supposed to have. So in this entire small project, you're seeing that there's one column, there are few exchangers, there are few horizontal equipments, horizontal vessels, there are few pumps. So pumps, you'll be having different type of pumps. Like by different type, I mean you must be knowing top suction, end discharge, or end suction, top discharge, top suction. So these are few type of pumps that will be going through. And obviously your utility has to be shared, because when you're going through pumps, you have an entire list of pumps, from vertical suction to your end discharge, or say a vertical top suction, your top discharge. All these type of pumps, why they are used, where they are used. So these few questions, obviously they'll be explained. Your few basic things of your equipments will be explained through in this piping session. Okay, piping training rather, that will be taking person. And then your utility of your control valves. So how we get the input from the control valve and how we monitor these control valves. As we can see that in the PNID itself, you see there is one particular signal. There's from this control valve, it's going to this level gauge. So these few niggles that will be explained in this in the PDMS training, that how we get to study the PNID. Studying the PNID is a very important part of your entire piping system, because once you get through your PNID, once you understand your PNID, it's very easy to understand your piping requirements. Like, by piping requirement, I mean that at which level you're supposed to model your entire control valve assembly, and where you're supposed to uh, how you're supposed to reach your valves, because placement of the valves, they are very important. The very important placement of your valves, because you have to take care of the height of the person, the minimum height of the person that can operate those valves easily. And even operation of the valves are very important, like, because few valves you'll see that they have a hand wheel, the other ones they have an actuator, and there are even few which are operated by a simple motor arrangement. So operation of these valves are very important. So you have to understand in the PNID itself that which of the valve is the one with actuator, which is one with the hand wheel, and like how you'll operate them. As you can see, most of the control valves over here that you're seeing, they are the one with the actuators. These control valves are the one with the actuators. So this one is like connected with the level gauge, and obviously you need to understand the process of the system. That is what many of them have a question, that they finish up the complete project and they do not know what was the process of the system. Most of the piping engineers, they have completed the complete project and they do not know like what was going through the project. Only what they know, that we have connected from one nozzle to the other nozzle, and this is what the type of connection we have done, this is the amount of elbows that we have given, this is the amount of elbows that was prescribed in the PNID, because this particular line had minimum number of elbows, so we have given these many number of elbows. This was the minimum possible. This is only what we know. But the very important part that has to be understood is the PNID. So PNID is the one basic part of the entire thing that has to be clubbed into one, and it has to be understood properly in order to have a feel of the entire piping system. Once you're through with the PNID, everything is a cakewalk. There's no problem with the complete system. Okay, so this is what we see, and then these are few of your pumps that are located over here. Okay, obviously there's one thing, you must have gone through this thing, that there are few lines which have one standing plus one standby pump. So this is one of the arrangements that we are seeing, and obviously we'll be doing that kind of piping also for one standby and one working pump. Because why it is important? Because the supporting of that particular pump, one working plus one standby, is very much different compared to the other one, that is the one working itself. So most of the time we see like what happens is, like, there's one working plus one standby arrangement for the pump. Because why? Now this is a very important question. Why? Because a plant, it cannot go into, like, say if one of the pump collapses, if one of the pumps stops working, your plant cannot stop working. Because no matter whether it's a process plant, whether it's your gas plant, or whatever kind of plant it is, okay, so it has to be taken care that your pump does not goes into collapse. So that is why we have this arrangement. You must have also seen that there are, in few of the plant, there is like one working plus two standby pump, and out of those two pumps, there's one pump which is a diesel pump. So these are few of the arrangement that we have. Okay, in one working plus one standby pump, both the pumps are motor operated. If there's a probability that this particular line, we cannot even uh, like we cannot even expect this line to stop working, or we cannot even stop the discharge or the suction from this particular section from this particular pump. So for that pump, we have an alternative. That is, we also keep a diesel pump for that particular line. So in case the power goes off, so we can run the diesel pump itself and start the supply in the line. We cannot. There are certain sections of the entire uh, your complete plot plan or your entire unit. There are certain sections that you cannot even bear to have like collapse in that particular section. You cannot have a zero output from that system. Like say your reactors. Once your reactor they go off. Okay, once your reactor they go off, so in order to restart your reactor, it requires certain amount of time. We all know like what is the input in the reactors. I hope that we all know this. What are the inputs in the reactor? Flue gases and all, oxygen and all. Like these are, and like in the piping system, obviously it will be explained by me that how your reactor works, because reactors are very important part of your they are also very important part of your system, your reactors. So everything will be explained for reactors also, how they go and how the piping done for the reactors, uh, because it's very important. Next is like this is your 3D model. So this is what your entire like after doing your entire piping, this is what your model is going to look like. The based on the project what we'll be doing in the training session, this is your model that is going to look like this. So there you see this pipe rack. These are your pipe racks. Obviously pipe rack piping is very important, so that has to also to be concluded by us. And pipe racks, your pipe rack will have like say it will have your simple straight runs, no inclined piping. Inclined piping will do for one of the sections, which I'll like show you later on, because you must have heard about this term. When we go to your flare lines, they are inclined at an angle, be it your header, be it your lines, so they are inclined at some angle. So that part of the piping will be done by us. In case of this thing, your pipe rack, obviously your simple straight pipe runs will be done, and your different type of T's will be coming into play. One is a pipe to pipe section, and the other one is your like weldolets, your weldolets and your sockolets. So like small legal things will also be explained, like say where your weldolets are used, where your sockolets are used, because there's a very precise difference between these two. Where do we use a weldolet and where do we use a sockolet? So this precise difference, you must know this. In case of wherever we require, wherever say there's a gas connection, you'll always see there's most of the time we are using a weldolet, because wherever we require a butt joint, wherever butt joint is required, most of the time you see a weldolet joint is used rather than a sockolet. So there is where we use your weldolet. So these precise things they'll be explained through. And obviously now we'll start with whatever things we will be learning in the entire training session. That is, one, we'll be going through equipment layouts. First, obviously we'll be studying the GADs. These are your GADs, and then like after you're through with the GADs and all, your all the views, your nozzle orientations and everything, when you're through with that, obviously we'll be going through your model. That this is your model, how you'll be working on. This is your nozzle orientation. This one is your one of the views, your front view. So this is what you'll be modeling in the system. As I told, equipment modeling, it's the part of a piping engineer. So a piping engineer has to do an equipment modeling also. So equipment modeling is very important. That is why you have to go through the GADs, you have to understand the GADs, and uh, you have to learn the basics. You have to learn the basics of the GADs, that how you're supposed to orient a nozzle. And when your GAD, you basically your designing has to be such that when you are taking out the GA out of your design, when you'll be taking the equipment GADs out of your particular model, it has to be perfect. By perfect, I mean most of the time we see that the nozzle orientation that we have done in the GADs, that we have done for the GADs, the nozzle orientations, they aren't correct. So that has to be correct. That has to be 100% correct. And how we'll get that 100% correct? Because we have to model them correctly. We have to check for each and every angle of the the equipment, the nozzles. And manual work, we have to do such kind of work so that our manual work is minimized to such an extent that later on when we are taking out the GADs, we get the minimum manual work onto it. Why? Because it minimizes the cost of your project, the man hours of your project. Because we know this, that whenever we are taking out the GADs from any of the say, be it SP3D or be it PDMS, whenever we are taking out the GADs, the problem is that we have to do some of the either manual work in the GADs. So that particular manual work becomes a huge amount of man hours into calculation. So that has to be minimized. In order to minimize that, you have to understand the GADs and you have to understand the basic concept of how to model the equipment so that your man hours are minimized, and model the equipment in the minimum time possible. Because we all are living in a competitive world, so everyone has to know some of the either trick of how to model equipment in the minimum time possible, of how to use some tools like offset tools, mirror tool, in order to just model the equipment as soon as possible. So that has to come into play. So these are your few equipment. This one was your this one was your column. In your column, there's a precise work on the nozzle orientation. You can see that these are few things, few of the nozzles over here and few of the nozzles on the tapered section also. And so this is what you see. This is the view. These are few of the at the angles. This is one your manhole. So manhole, obviously your manhole over here is, that particular manhole is not having your davit. So like you have to model your davit separately and you have to come and stick it over here. So modeling of a davit is also another section into it that has to be again done by you. So equipment modeling, again over here you have to show your horizontal equipments also. This is the horizontal equipment. These are particular these are your nozzles. This one is your saddle. So obviously saddle and all, you have to model it again. And this is your exchanger. Again, as I told, that exchanger, you have to take care of it. You have to model the exchanges. You have to model it very carefully, because the length has to be taken care. So the overall length, whenever we are modeling the equipment in PDMS, it's very important that after modeling, although say your model does not looks very much like a GAD, say if it does not looks like, in most of the project what we do is we have shortage of times. So what we do in that case, if our project is very much precise and it's like the man hours are very less, so what we do is we cut the man hours into equipment modeling. Now how can we cut the man hours? We simply model the end-to-end dimension of the equipment, because what we require is the piping, what we require, the piping distance has to be accurate. Okay, now piping distance, how will we it accurate? Because the end-to-end dimension of the equipment has to be accurate. So say end-to-end dimension, what I mean, that the dimension of your equipment from this end to your this end, and the shell end, this one, to this end, this has to be 100% correct. So when this is correct, then what happens is your piping will be obviously correct, because you'll be taking care of the clashings and everything, that there's no such line that is going through near the equipment or anything. You'll be taking care of the equal amount of space through the equipment. When you'll be like going through your piping layouts, you'll be taking care of this thing. So end-to-end dimension, they're a very important thing. So whenever you are like modeling your equipment, you have to take care of the end-to-end dimension. That has to be correct. Okay, and then obviously your pumps. This one is your side suction and your top discharge pump. This one side suction, top discharge, and this is a layout, and same goes for this. I'll just quickly brief you through this. And this one is a top suction, top discharge. So you'll be modeling these pumps. Okay, and then comes your structural foundation. Structural foundation comprises of your grid and all arrangements. So you'll be taking care of the grids and the other foundations. Like this one is for the columns. These small foundations that you see, these are for your pumps. These foundations are for your columns. you'll see columns coming onto this particular sections. So columns will be hanging onto it. This is what you see, your equipment is coming through like this, and basically a column. So this is your MCC control room. Obviously, you have to model this also. Structural modeling is also once again part of a piping engineer. Most of the piping engineers say, although they are not from a structural background, but yes, you have to work onto it. There are no if and buts. You have to work as a structural engineer also. So structural part will also be told by me. Whatever structure and how the members are to be modeled, what type of members are to be chosen, how the load calculation has to be done for a particular member, and everything. Okay, and this is your MCC control room. So like how you'll model this MCC control room, it's again like the windows and all everything. So it's very important. So this is a structural model that I was talking about. This is your complete level layout. This is the pipe rack. This is your, these are the levels, like I'll be modeling the grids for this level. And then obviously once you're through with the grid modeling is one of the basic part of PDMS. Once you're through with grid modeling, you can easily understand like, okay, this is how I'm supposed to model the complete structure. Once your grid modeling is done, simply need to choose the intersection of the grids and obviously place your column, and giving, what you'll be doing is like giving the vertical height to your column and choosing the structural member for the column, like whether it's ISMB 500 or whether it's ISMB 250, 300, whatever is the specification of that particular structural member. So you'll be selecting that particular specification and you'll be modeling this complete section, and that's true. So then comes your equipment JD. This equipment JD we are going to have, we are not planning anything for the equipment JD. What we are doing, it's simply that we are whatever equipment JD, this is a prefabricated equipment JD. So we'll be having this equipment JD, and what we'll be working on is we'll be working on placement of the equipment. So how, again, it's very important. Like say a senior engineer has shared an equipment JD which he thinks that this is very important. This is what has to be the location of the equipment. So once he has shared, now you as a piping engineer, obviously when you'll be like working at that particular post, you'll be also working on the equipment JDs. But say if you're working on a lower grade and you have been shared an equipment JD, now the placement of the equipment is very important. Now how you will place the equipment, how you will measure the dimension, so your placement of the equipment has to be accurate. Okay, so that particular part will be taken care. And now how we do it, again will be shared in the model. Okay, so this is what we are going to go through, and placement of the equipment that you can see, like this is your heat exchanger. The other one below your heat exchanger, there's a horizontal vessel. If I'll zoom it out this way, there's a horizontal vessel. This is a column. Again, this is a exchanger. There we can see that this over here exchanger, this is a bundle removal process that has been taken care. So again, the bundle removal process, particular this amount of space has been given for your bundle removal. And again we come to the pumps. So these are the pumps placed below the pipe racks, and like this is how we're going to proceed. This is your pathways, like this is your pathway. So again, like placement of the columns is very important, because what placement of column is very important section of the equipment layout. Again, that will be again explained in the training session, how we place the columns, what are the things that, what are the precautions that we place the column, because column is not a small equipment that you're just going to bring it with a simple crane and just going to place it. It is a very, very big member, about like 20 to 25 meters in length. So that has to be taken care, like how you are going to come with the column and how you're going to place that particular column. So that has to be taken care. So obviously your column, it's always close to your, in proximity with your roadways, like these are your access ways. So it is somewhere close to your proximity, like this. You won't like place a column somewhere over here where there is no access. You'll place it somewhere over here. So this is what you're going to take care. And obviously then this is your equipment layout, whatever equipment JD that was there. As per equipment JD, your equipments have been placed over here. And then this is a piping. This is the piping that what are the piping sections, like your control valve assembly over here, your pump suction, your the one which I was talking about, one working plus one standby pump. This is your one working plus one standby pump. And like how you're going to support the lines. So again, supporting of lines is very important, and the type of supports, again, they are very important. So like what type of supports are to be used, how we are supposed to model those supports, everything will be shared. Okay. And whenever we are piping, very important thing is, like, when we get into the basic of piping, it's the first thing that comes into our mind is how we are going to support our piping. So supporting your piping has to be very clear. Whenever you are modeling your pipes, the modeling of pipe has to be such that you take into your consideration that, okay, when I'm going to from this location, say for example, when I'm going from this like tops, I guess this is a top section, top discharge. So when I'm going to this top section, top discharge rather, or like whatever it is, I guess this is smaller size, so this will be discharge. Okay, so this is a discharge line. So whenever you're going through discharge line, so whenever you're modeling beneath this pipe rack, so it has to come, okay, I can take a simple overhanging L section or an inverted U section support for supporting this particular pipe. So whenever you are modeling, support has to automatically come into, like, at these particular amount of span. Obviously span calculation will be told by me, like how you're going to calculate the support span for the piping. This is a support span, this much of your support span. So you have to take into consideration that this is a pipe, this is the size of the pipe, this is the amount of fluid that you're carrying. Okay, and like based on the density of the fluid. So this is, and these are particular supports at which you, at particular location at which you're going to place a support. So placement of support is very important, because if you do not consider placement of your support, it might be very uneasy situation when you are placing a support, or when, say, a particular pipe goes into stress, and your stress engineer says, okay, like, see mate, this particular support is not correct. So you have to defend your piping and your supporting also, that I think that this is correct, and this is the particular this is the exact location that where you can support this particular pipe. There's no other location that you can support it. Might be, like, situation might arise that a particular line is not getting saved into Caesar, and it requires a support at that particular location only. Then obviously there's no other choice, you have to give a simple member to it. You have to either give a tertiary member to it or a secondary member in your structural layout, and you have to support it if if your stress engineer is not agreeing to it. But if somebody comes with a comment, your piping has to be this logical that yes, you can defend your piping and your supports also. You have to work in that kind of fashion. Like, say, if I'm commenting over your support, then it has to be up to that level, it has to be up to that mark that you can defend your supports, that yes, this is what I think, that this is how this has to be supporting, and this is what I've thought of the supporting while I was modeling this particular pipe. This particular run of the section is having this many number of supports. So this is what has to go through a piping engineer. You have to be very much through with it. So again, as I was telling, again, this part of piping. So this is the one with your slope, as you can see, piping of the line with like 1/50 slope. So this particular pipe is coming on a slope. Again, this line is very important. Modeling of this line is very important. Why? Because most of the time what we do, it's we support this line over here. So supporting, again, it has to be taken care. You have to feel the growth of the line. That is what we say in piping. Basically in stress, what we say this, that you have to feel the growth of the line. Now the growth of the line again will be explained by me, because my also work is your stress thing. I also work on stress. So obviously, now how you will realize the growth of this line, because this section is fixed, this one is your fixed, so these two joints are fixed. Now obviously the growth will be consumed by the elbows. Now how the elbows will be moving? Now elbow movement will be again sponsored by the length of your pipe. So what, the more the amount of length, more the amount of growth. Now that simply comes with your formula. We all must have like gone through this formula in our engineering days. You must have heard this term over delta L. Delta L is equals to what? Delta L is equals to alpha into L into delta T. So delta T obviously your temperature difference. Alpha is your, if anybody can like answer in the comment section, what is alpha? Let me see, like, are you hearing to this or not? Just in order to get your consideration. Anybody over here who know the what is the like what does alpha stands for in case of delta L? This is a formula. Alpha into L into delta T. So what does this alpha stands for? Thermal coefficient, or you say your expansion coefficient? And what does this depends on? It depends on your material. Why I say material? Because if you compare SS to a CS pipe, so the amount of growth that is going to have, SS is going to have 1.4 times of your CS. Obviously, growth in your SS pipe, it is considerably more compared to your CS lines. So that has to be also be taken care by you. That the growth, whatever is being shown, that is 100% correct. Okay, so again, you have to take into care where you're supposed to give your elbows or your supports. So again, coming over here, obviously there has to be a guide. You can give a guide with this thing also. Say if I'm coming with this particular line, I can give a guide, vertical guides. Now the type of guides that has to be given in case of a vertical support, again, that particular support standard will be shared by me and obviously explained by me that this is the amount, this is the type of supporting that you'll be doing, and this is how you'll be modeling your supports. Like say if we are going to go to one of the these things, so these are the kind of supports that will be modeling. Okay, then again, modeling of these supports, this will be through the standards. Like this is how you'll be modeling the supports, the U bolts and everything. So again, modeling of this particular support, that will be done. Okay, that will be done in 3D piping. So now coming back to this, again, supporting of this line is very important. You're not going to support this line over here in this section, in this small section that you see. You will not support this line over here. Now you will only guide this line, one guide, two guide. If you want, you can give a vertical stop as well, which we call it as a limit stop, as an axial stop. You will give one limit stop or one axial stop somewhere over here, so that whatever growth is being coming in this line, this is like bifurcated into two halves. One is whatever growth is having over here, and the other part is this. So this particular nozzle is completely isolated with whatever amount of growth you're getting over here. So this particular nozzle will only be affected by this amount of growth. Now since you're having an axial stop over here, for this complete amount of growth that will be coming into this section of piping, this will be transferred to this elbow. Now this elbow, what it will behave like, it will behave like it's moving downwards. Now when it will start moving downward, this one will move upwards. So there has to be no support over here. There has to be no support, or if you want to place a support, it has to be perfectly working as a fulcrum for this particular line, because it cannot, like the line cannot lift up at this particular position. So if you're placing a support, it has to be somewhere in the center. It has to start working as a fulcrum about which both this elbow has to work. So you have to take care, like whenever you're supporting a line in between two elbows, whenever you're supporting a line between two elbows, that particular, say if the span is not very much, if the span is not more than 3 to 4 meters, if you're placing one support, that particular support has to work as a fulcrum. about which both your elbows start playing. So this is how it's supposed to work. Now you place one support over here, the other one over here, and obviously no supports near the nozzle. Over here, you are not supposed to place any support, because why I'm telling that, if you place a support near the nozzle, what it does, it restrains the movement of the pipe. Now, whenever you're restraining the movement of the pipe, you're adding on stress to the pipe, to the nozzle. So that is how you work onto it. That your nozzle is not supposed to have any amount of stress, any amount of extra stress or imposed stress by you. So that has to be taken care. So the stress on the nozzle has to be the least. Okay, now we go on to the other sections, that is different OLEDs. These are your OLEDs that you see. This one is your credit section. This one is your this thing, kind of a union that you can say, this one. And these are your T's and all. This is reducing T, so these are OLEDs. And obviously next we come on to is your the pipe rack. Obviously supports at the pipe rack, they are very important. So supporting for insulated and a non-insulated line, that has to be taken care. Whatever support you're getting, be it for an insulated line, be it for a non-insulated line, that support has to come clear. And how you will support it, what has to be the length of your shoe, what has to be the placement of your shoe, at which particular, say, like whenever we are placing our supports on the pipe rack, we must have gone through this term that this support should be with a guide, this one should be a simple resting support, this one should have a limit stop, this one should be again a guide. So what are the criteria that we specify that this particular support should be a guide, this one should not be a guide, this one should be a limit stop? So again, that criteria needs to be important, that this is the criteria that we need. So that thing has to be explained again, that this is your non-insulated pipe, this one is your insulated pipe. So this is how you see. Now how difference, how come we have taken out? Obviously whatever insulated pipes we are having, that insulated pipe, they are supposed to like have a shoe. They will not rest directly on your this thing, on your structural member. Okay, they will not directly rest, they'll have a shoe. Now shoe, what is a shoe? Shoe is simply like, if I can explain you over here, whenever you're saying that this is a shoe, it's simply, you must have seen your eye section. This is the eye section. This is the eye section. My drawing is not that good, so you can pardon me, please. Okay, so what you do, basically you cut it into two halves. Now you slit it into two halves. So what you will see is something like this, right? You will see something like this. Now this particular thing will be directly it will be welded to your pipes. It will be welded to your pipes. Now this is how your support is going to work like. Okay, now if you want to guide it, you can obviously place something over here. You can place either an angle or like either some plates over here, and this is your guided pipe. You can rest it on your this thing, on your beams. You can rest it on that, and like this is how you're going to support your insulated pipe. And when you're coming to your supports for the non-insulated pipe, then they obviously they will rest directly onto your structural member, and if you want, you can U-bolt it. You can proceed it like this. So this is the kind of supporting that you'll be going through. So pipe rack supporting is very important part of your piping, so that will also be explained. Then finally we come on to your isometric extraction. Now how your isometric has to be extracted, what has to be the template for that, and like how you come to know that whether your isometrics are connected or not, what are the errors that you're getting. So all that will be explained also, like how you can check your isometrics directly before without this thing, how you can check your isometric without even coming onto this your draft section. Okay, because simply what is the problem, that when we are taking out isometrics, we are taking out into different modules. Okay, different MDBs we are choosing for this. So for taking out isometric, we choose the draft module. For taking out GS, we choose, for taking out isometric, we choose iso draft module, and taking out for JDs, we choose the draft module. So this is what we do. So this is a piping JD. Again, your piping JD has to be perfect. Your piping JD, again, you cannot like make an excuse for your piping JD and you go on to a manual work. Your piping JD has to be perfect. The dimensioning has to be absolutely correct. So something like whatever JD is extracted, you're not supposed to again do any manual work manual work onto it, because that again increases your man hours. Be your piping JD, be your equipment JD, everything has to be correct 100%. Your nozzle taggings and all, like tag for your nozzles, tag for your equipments, location of your equipments, meeting your X and Y directions, everything has to be perfect. Every equipment has to be located in the GAD itself. Okay, as you can see, like there are few dimensioning done for this also. This particular has been located in X, it will be located in Y also. So because once you throw your JDs to your piping team, your team on the site, they are easily able to understand it, that okay, this has to be the location of this particular equipment. You cannot uh, like you cannot you cannot counter anything, like say you throw up a particular GAD to your site and your persons, they are not able to locate the equipment. Location of each and every equipment is very important, so GAD has to be taken care. Okay, so this is what we will be doing through in your entire piping course. This is what all we'll be studying. Okay, now I'll just quickly brief you through the software also. What are the important sections of the software? Because I have told you like how you're supposed to work on the GADs and all, but very important section is how you will work on the like software, because whenever you're working on the GADs, the software is very important part. Why software is very important part? Because your GADs, they are dependent on your hierarchy. So hierarchy has to be 100% correct. Like you can see over here, this is a stabilizer site. So I made a stabilizer site, there's a zone onto it, then on the zone we have the equipments, and when we go onto the equipment, you see certain sections into it. These are your cylinders, this is the insulation for the cylinder. So cylinder is having, your equipment is having an insulation, so insulation has also been shown. Then comes your nozzle. Okay, so this is how you're supposed to locate. Now what you can do is you can locate a nozzle in a subsection also. Now how you will do that? That simply, again, you have a particular command where you can change your hierarchy also. Like say if this hierarchy, I'm having a problem with this hierarchy, I want this particular nozzle to like so in a subsection. Now why in a subsection? Because say if tomorrow I want only my cylinder and my nozzles to come in. I want my cylinder, I want the exterior part of the cylinder and the nozzle just to show my nozzle orientation. Say I want only this part. So obviously I can select that part and come in, because in the industry each second matters, and more competitive you get into it, obviously better you are. That is how you define a workman in the industry. The lesser man hours, who consumes lesser man hours, more efficient he is. So that is what we do. Like if say for example I'm removing this, I have this particular equipment, this particular zone is having these many number of equipment, the equipments have been arranged. You can see the pumps, these are your pumps. Okay, so you can see this pump, this one is your this thing. You can see one pump over here, this one is your centrifugal pump. So both the pumps are centrifugal pumps. The one you see over there, just give me a sec. So So I was talking about this particular equipment. Okay, this is the exchanger. I'll come on to the pumps later on. So this is your basically your equipment. So what you see in this equipment is you see the nozzles. This is a bundle removal part. Okay, now this entire section has to be modeled as explained by you. Okay, so next we move on to your column that this was what I was basically explaining in this entire section. Like if you remove this complete if you complete on the remove current element from the draw list, it will remove my complete equipment. If say I want my particular sections to come into it, okay, like say this particular thing, I clicked onto it. Okay, I clicked onto it, and this complete equipment is coming into play. Now what I want, I only want the nozzle section or a particular part of the equipment, so that again I can model into a sub equipment, and my hierarchy has to be 100% correct. So hierarchy has to be taken care very importantly in this particular plant. So if you check onto this particular equipment, there are certain hierarchies into it. There's a sub equipment over here, and then there is another sub equipment over here. So these two sub equipments, they're having something. Okay, so this thing is what I was saying, that it has to be taken care. The hierarchy has to be there. So sub equipments and then sub equipments to another sub equipment. So that has to be taken care. Again, there you can see many number of nozzle into this system. In this column, you can see many number of nozzles. But the problem is that these particular nozzles, whatever they have been shown, these particular nozzles could have been shown with a this thing, with a sub equipment, which would have been much more easier to understand. So that is what we are supposed to get into the, like when we are getting into the modeling part, then obviously we'll be working onto it. And then these are the pipes. Now how you model your pipes and all, like I'll brief you through your gaskets, flanges. Obviously when you're modeling your pipe, the important part is you need to refer to your PNID. You have to look into the flow of the piping. Whatever is the flow of your piping, you have to take it into consideration. Then comes your T. T is a very important thing in your piping. You have to model your T properly, your arrive and leave at the T's. So that has to be taken care. Like say if I'm coming to a T, you can just see some sections in this T. These are your instrument that are over here. So this is your flow meter. Now there's a flow meter, there's also a temperature element into it. You must have seen, like at the temperature element, what we do is we whenever we're modeling a temperature element, if say it's a smaller size line, say it's a line of 2 inch, we give certain reducers. Now why do we give those reducers? Why do we want to increase the size of the line in order to like install, before installing this temperature element? Why do we do that? Obviously because there are certain requirements for a temperature element. The probe has to go up to certain distance in order to have exact amount of reading, right? Now how is that probe? Is it a tapered section? Why do we use a tapered section? Why not a straight section for that probe? Now that particular small niggles into your piping, that will be explained again. Okay, and now what we do is there's some problem with the mouse. So basically, like I'll just brief you in this manner. Okay, let's like have some isometric view of this. So this is what you see. This is like these are your pumps. So if we get to the PNID, how can we locate these pumps? Say this is my line. This particular line is like the number of this line is 100B1. Okay, so 100B1 in the isometric model. So in a PNID, 100B1 was somewhere. Okay, this is, I guess this is your 100B1. So obviously your tag for the pump, it's like P1501. Okay, so hopefully these are your pumps. No, they aren't. Okay, how about this? Okay, this one is, and this one is. So this has to be taken care. So again, your modeling of the pump, it's very important. Now when you're coming to the T section, again, what you will see in piping in PDMS, that is why I say PDMS is one of the basic softwares. If you're through with PDMS, you can like learn SP3D in a very quick time. I have myself done it. Okay, now what are the basic requirements? That you understand the basic things. That is, when you're modeling a pipe in PDMS, you input the components. You input the components by yourself, each and every component by yourself. Like whether it's for the valves, whether it's for the gaskets and all, you input each and everything manually. So you anything, like we all know the difference between driving a car which is having the complete gearbox section and the one which is being driven by a clutch. Okay, so we know what an automated car is and what a manual driving. We know the difference. So this is somewhat the difference between PDMS and SP3D. Same thing was being explained by me earlier. So this is what we will do it over here. So obviously this particular section, this is your upstream line, this is a downstream line. Again, downstream and upstream, if like say there's an orifice, there's an orifice, like how your orifice has to be modeled, whether it has to be like what amount of distance, 15D and 5D in the upstream, the downstream, how you're supposed to maintain that distance. That section will be again explained very well. Okay, now we go on to the remaining part. This is the piping, how you're going to support this piping, and this piping has turned up to an equipment. I guess. Okay, we'll just switch on to the equipments, all the equipments. Okay, this has turned on to a this thing, the exchanger, and this is a bypass assembly. So this is what all we'll be learning in this entire section. And obviously the isometric, like how we are going to check the isometric. Say this is our isometric, and how we will get the isometrics into the report, and this thing, and how we'll check this complete section. Okay, so this complete section will be briefed by me, and if like you have any queries, you can come up with your queries now, if any of you have any questions. Anybody, any question? Bharat, Govind, Himanshu, Kishore, Nishant, Pradeep, Prashant, Prateek, Raghu, Steve, Vilpandian, Yogesh. Anybody, any question? You all can turn on your mics and like.
No, I don't have any question.
Okay.
Hello.
Any question regarding piping? Anybody?
Hello, Anurag.
Yeah. Please.
Hello, Anurag. I have joined late actually, 12:15 actually. So it's your session is already over. I think So
Yeah, if
you are having
like,
any?
if you want to go through the recordings, you can just contact Nitesh once. He'll share you the recording.
Okay, so that's a great. That's a great thing. Yeah, you are doing. So you explained everything means regarding piping and equipment, right?
Yep. Like
And
basically what I explained, like how will we approaching the training session. This is what our motto was, briefly to
okay,
brief you out, like what will be learning in the training session, and
okay,
like what will the basic things of piping that we are going to understand in this complete session. Like small
okay.
things to the big things. So I'll
And
explain.
what about supporting also you have explained or remain?
Yes, yes. Basic of the supporting, like what do we consider when we are working on supports? What do we consider them? And how will we modeling the supports? We looking at the standards, support standards. Modeling of the looking at the support standards is very important because the length of the supports and everything has to be taken care. And obviously
Okay,
patching of the piping again, it's an important thing. Like what has to be the gap between the two pipes which are running parallel to each other. So that has to be taken care. So everything has been explained.
okay. And
Okay,
can you tell me the difference between PDS, PDMS, and E3D software? Means there is many basic difference or any major difference. That's
that
all.
is that is
That's
that is what I explained earlier. So like when you go on to SP3D and or like E3D, so these softwares are one of your advanced version of your PDMS. Okay, so like when we are through with PDMS, you can easily like it's one of the easiest softwares to run SP3D and E3D. But PDMS is one of the basic softwares. There is where you get each and every input into the system, and both these softwares are equally used in the industry. Like someday or the either you have to learn PDMS also, you have to learn SP3D also, you have to learn E3D also. Okay, so both these softwares are equally learned. Okay, but if you go for a PDMS, you go to the refined version of it to it. Like we know the difference. Like how better we can get is better we can get into the industry. Obviously, when we go through the basic things. So basic, obviously, you should always go for PDMS. That is what is the basic requirement. Okay.
okay. Thanks.
And few more questions over here. Nishant has asked, obviously, the duration. Sorry, like I forgot to mention the duration. Duration, obviously, it will take around 40 to 45 hours. And like also it depends. It can go longer also. It can go lesser also. It depends like how much time you're giving. And like 40 to 45 man hours do not include the amount of man hours that you are spending on the system, because a lot of input has to be given by you also. Because obviously whatever GADs I'm sharing, that has to be properly modeled by you, and at the same time whenever you're coming back to the session, that particular GAD has to be very well explained by you, that yes, these are the things which I thought and this is what I've modeled. Obviously the basic part, the starting part will be explained by me, that this is how you're going to supposed to this is how you're supposed to approach your GAD. But working on the GAD and the other things, like the complete modeling, that has to be done by you very well, and then only I'll put on my input. Okay, I put on the corrections. Okay, this is okay, this is okay, this is okay, and this is what you're supposed to change. Because until and unless you don't put your efforts, I make the complete effort, you gain nothing out of it. Okay, so you have to make an effort onto it, and then I put my inputs. So that is why the complete duration of the course is like it's around 40 to 45 man hours. Sorry, 40 to 45 hours. Okay, and like that is the amount of time it is going to take. Okay, the complete thing, the isometrics, GADs. I know it might sound a longer duration, but yes, it is going to take that much of time, and the timing will be flexible. So okay, there's a question
Actually,
from
I have one question.
uh,
Hello.
just give me a sec. There's a question from Raghu. He has said, hello sir, this is Raghu. I'm working as a CAD design engineer. I want to change my domain to piping. If is if worth to change my domain, and what? Yes, obviously. See, anybody who's working as a CAD design engineer, everybody who's working as a CAD design engineer, the first thing that comes into your mind, the switching on to piping. Once you switch on to piping, the next thing that comes onto your mind, like, why not to stress? This is how it goes in the piping industry. Anybody who's a CAD design engineer, he goes into piping, then to stress. So yes, it's very much good. Obviously, it'll be a growing profile. Whatever profile you're going to throw to anybody, it's only going to show that yes, you have grown in your industry. You have like not stuck to one particular profile. So it's very important. It's very important that if you get opportunities, you switch your opportunities from a like CAD design software. It's very good. It's very like CAD design and all. But PDMS, anything like adding on to it. Myself, I'm learning. Like currently, I'm working as a stress engineer, but as a layout engineer also. So I'm also learning. Like I'm also adding on to my profile. I'm also learning AutoPipe. Okay. So things I'm also like adding on to my profile. So you should never get stagnant. Whenever you get stagnant in any industry, that is where you are decreasing your value. So you should never do this. Always you should this thing add on to your value.
Hello, Anurag.
Yeah,
Can I ask one question?
please.
Nowadays, you know that Corona pandemic situation is going on, and
Yeah.
lots of persons and people are facing difficulties in not only oil and gas petrochemical field, but also other field also. So it's majorly impacted. So how much time will it be required to recover all this situation? Means how means there will be boom. Means can you tell the forecasting just for the sake
Yes.
of means convenience? Just thanks,
Okay.
huh?
Okay.
Okay.
No issue. Okay. So simple answer to you. Like I guess we all are using share market. We all are into share market, and we all know this thing that the oil prices, they are getting better day by day. The per barrel costing is increasing. So obviously there's always a boom. You must have you can even see that graph. There's always a boom when your oil prices, they get higher. So whenever your oil prices, they are getting higher day by day, you can expect of a boom in the this particular sector. As we can see, like currently there are a lot of jobs being thrown by L&T. Like since it's my industry, I know it better. So L&T, like they are throwing up a lot of jobs. Currently they have got many number of projects with them. They have coded for a lot of projects. They have even got projects at like 50% of the amount of code that they have thrown. And so they're getting a lot of projects currently. And even like there's a recruitment going on in L&T for a piping design engineer. If anybody wants to apply, they can apply it over there. And yes, boom and
Uh,
everything, it will come.
but one question is there, but there is okay. Boom will definitely going to be there in
You can expect
coming
in
6 months or 8 months.
6 month time, you can expect.
No, that is
Yeah.
correct. But what about the impact? Means already we have survived. Means many of the persons are getting lesser salary. Means 30% cut off, 40% cut off, or even they lost their jobs also. So
Yes.
means will they recovered over their salary? Means what they were expecting at past 9 months or 1 year back. So will they get that things? Means just asking you. Means is there any guarantee or is there any so,
Kind of a personal question, but it's okay.
yeah,
Okay.
yeah.
So you can expect like this 1 year loss, everybody is like adding to the balance sheet. What is gone is gone. This is what most of the person is saying. Okay. So you can see the cricket World Cup 2020. There was a World Cup being scheduled in 2020. Now it is being scheduled to 2021. So it's the same thing. And obviously your football matches and everything, they have been rescheduled by 1 year. So this particular 1 year is something like it. What is gone, it's gone. You cannot like you cannot go for like say
Anurag, that what not I am not asking that one. 1 year what we did, what we got. I'm not
hmm,
asking that one. But in future, when we
hmm.
get any salary or any perks or
You
any
cannot
yeah, yeah, I'm talking
excessive
about that only. Yeah.
any X amount. That is what I'm saying. Indirectly, I meant that. Indirectly, I meant that. Like, I'll clear it out. If say you have an X amount in that particular year, okay. Say you left in 2020 March, okay. Now, if you're joining after 6 or 7 months, you cannot expect like your salary to be 1.5 times of your X amount. Obviously, the hike will be some ways similar, because what currently companies are doing, they're quoting for the work at around like 50% or 70% of the normal calculated man hours. Okay, that is what they are going quoting in order to get the jobs, in order to get the work. So you cannot expect a salary that is like say 1.5 times of your X amount, because ultimately you are sitting idle. Okay, like say if you are not getting that much amount of work, or if say you're not getting any work, say, so it does not adds on to your experience ultimately. So why will you be getting paid to it? Okay, obviously anybody gets paid to it the amount of the more the number of projects he has worked on through his life. More the number of projects you work on, more experience you add on, and more amount of salary you get. That is why managers are getting more number of salaries, because more experienced a manager is, better salary he gets. So it's the same thing that we are expecting over here. So whenever you're coming back to the industry, or whenever you're joining back, so obviously you can expect like 1.1 times, or even like a lesser salary, or a comparatively same salary what you had earlier. You cannot expect a rise in the salary. Like this is a HR question, but like I'll answer it. You cannot expect that thing. Okay, I'll quickly like take a few more questions. There's one question being asked by Pandian. Yes, I have also same kind of question like Raghu. Okay, man hours, that was it, I guess. Okay, Raghu was for this thing, CAD design and engineer. Fine. Yes, you can work onto it. And Nishant has one more question. I will call you personally. Okay, fine. Okay, so thank you. But I changed my domain to piping now. Nowhere I will consider. I will be considered as an experienced candidate considering my previous experiences. What would be your suggestion? See, if you're working onto this complete thing, like if you're adding 1 year even experience to your PDMS profile, nobody works onto it. Okay, say a 1 year experience guy is almost equivalent to the one who's taking a good training. Okay, somebody who's taking a good training and who's very much serious to it, and who's very punctual for his training, I guess he understands the thing better and he can communicate the things better. So you can show up as a 1 year experience profile, and like you have your own this thing is like something kind of a personal question. I'm just explaining it to you, can take it on like one-to-one answer, that you have worked on certain projects. Few people must have worked on the same project who are working on PDMS. So obviously you can show that project, that yes, I have worked on this project as a PDMS as a piping engineer working on a PDMS profile also. So you can show it that ways. Okay, so this is how you can work onto it, that okay, with 1 year experience, like the questions even which are thrown to you for a one year experience, because like I have gone through a few of the interviews lately. What they do is, well, obviously they're not calling you at site for your interviews. What they do is simply they ask you the hierarchy. They ask you the hierarchy, like how you're supposed to model. That is what they do. So you can simply like learn the hierarchy, like say for modeling an equipment, what is the hierarchy? For modeling a particular pipe, what is the hierarchy? How you choose the component? How you like create a GAD for PDMS? How are the hierarchies? How you do it? That is what they're asking, and you can simply explain it. Fine, you're in. That is what they do. Okay. Okay. Next, I hope I have clarified most of the questions. One more clarification that I need, if I will learn PDMS, the software like PDMS automatically, it will teach me piping calculation, or I need piping design as separate? No, like piping calculations, it's a broad term. If you can be specific with this, piping calculations, it's very broad term. In piping calculation, you have a lot of things. Okay, say like for weight of the pipe, supports, it's a very broad calculation. Piping span, a lot of things come into piping calculation. Myself being a stress engineer, I get into a lot of things. Piping calculation goes into piping schedule, piping calculation goes into SIFs. Like there's a lot of things which add on to the piping calculation. If you can be much more specific with this piping calculation, we can expect a positive thing.
Yeah, Anurag, actually, I have one question.
Mm-hmm.
Can I? Hello?
Yeah, Govind, please.
Yeah, actually, there is one thing I heard from my seniors that this PDMS, E3D is the advanced version of PDMS. So was it true?
Mhm. Yes, that is what I'm saying. That is what
Okay.
I told to you earlier. These are
Oh,
advanced version onto it. Like earlier
oh,
you had this simple camera. Now you have a very defined camera, which we say it's the 4K camera. But obviously, somebody who knows to operate that basic camera, obviously he can operate that advanced version of the camera also, 4K camera also. Might be he might be learning few extra tricks, but the aperture setting and everything that remains the same. Do you understand my thing? So that is what I'm saying. That basic has to be clear.
okay,
Anything
but
that
what about the scope and opportunity in future for this software? Means if I learn, means in future it will be useful for me.
see recently one of my friend has got selected into L&T based on the same profile as a PDMS designer. So like L&T Chiyoda, okay, LTC. So like you can expect like I don't need to add on anything to it. You can see the opportunities.
Yeah, okay, okay.
Okay, any more question? uh, well, Pandian, you have to be certain specific about it, but yes, few part will be explained, like piping span calculation will be explained, how you will calculate the weight of the pipe, that will be explained. So that part will be done. Okay, few part will be done. And obviously, if you want some personal help, I'll like share the PDFs and all, so you can work, you can learn from that PDFs, whatever thing extra you want. Okay. So I have answered everybody over here who all had your queries, and thank you everybody. Thank you for staying that long with me and like cooperating me like for this much of time. Thank you all. Thank you very much.
Thank you, Anurag. Thank you.
Okay, thank you.
Thank you.
Bye.
Hello, Anurag.